All right, this is a video going over for A2H section, the the precursor to section 1.10 worksheet, kind of the pre-lesson there for that, talking about even and odd functions. So let's go back to some basic graphs we likely know. So let's look at f of x equals x squared and g of x equals x cubed. So first, let's just remind ourselves of the shape of both these. So the y equals, or f of x equals x squared graph is a quadratic, opening up, symmetric across the y-axis. And the g of x graph, and this you may be less familiar with, looks like this here. Okay. So based on these two functions, let's also do another thing. Let's just go through the exercise of finding a couple of points. So f of 2 in this case would output 4, whereas f of negative 2 would also output 4. Let's do another. F of, say, 13 would output 169, and f of negative 13 would do the same. Because you're squaring it, both are becoming positive. Okay, now let's look for g of x. Let's do a few points here. If I did g of 3, I would get 3 cubed, or 27. But g of negative 3, I still have that 27, but it'd be negative 27. Similarly, if I did g of 4, I would get 64. And g of negative 4 would be very similar. Still have the 64, but it'd be negative 64. And you can even see from the graph, positive x values are resulting in positive y values, and negative x values in this case are resulting in negative y values. Okay, so let's then go back to the graph. Let's talk about the symmetry of y equals x squared. If you notice, it's symmetric across the y-axis, meaning if you were to fold the graph across the y-axis, it would line up. And I recognize with G, maybe you'll be less familiar with this, but it actually has origin symmetry. And what that means is if I take this part here and flip it over the y and then the x, it'll line up. Or I could have flipped it over the x first and then the y, and it should line up. Same if I were to take the other piece. So flipping it over both the x and the y, the graph should line up. Well, it turns out that y equals x squared, or f of x equals x squared, is an example of an even function. And y equals x cubed is an example of an odd function. And let's give the formal definition, or the algebraic definition, of an even function. An even function means when I plug in a negative x value, I get the same as if I plugged in the positive x, its positive counterpart. So same output regardless of the sign of the input. Whereas to be odd, when I plug in negative x, I kind of get the same output as the positive counterpart, but it differs in sign. So you can see how in this example here, putting in negative 3, I still got the 27, but it was opposite in sign. It was now negative 27, whereas before 3 went to 27, negative 3 now goes to negative 27. By the way, you could have this situation. So say I said h of x is odd, and we know h of 2 equals negative 5. I might ask, what else do you know? Given it's odd, if you only know h of 2 equals negative 5, is there some other point you know? And you do. Because it's odd, you know that h of negative 2 won't be negative 5. It'll be opposite in sign to that. It will be 5. So don't assume that positive x values go to positive y values. It doesn't mean that. It means if these are opposite in sign, so are their y values. if it's an odd function. If it's an even, they should be the same, the y values. Okay, so say I want to test if something is even or odd. So let's do this example here. So example 1, even, odd, or neither. By the way, most functions are neither. Okay, so let's do a of x equals 3x squared minus 2 absolute value of x plus 7. So to test if it's even or odd, I plug in negative x, always start there. If I plug in something opposite in sign, I plug it only in for x. And then let's simplify this. A negative x squared is going to just be x squared, because that negative 1 squared is just going to be 1. Minus 2, well, negative inside the x is going to be the same as absolute value of x, right? The absolute value is going to make it, if it's negative, it makes it positive. If it's positive, it stays the same. Plus 7. Okay, so what I notice is when I put in negative x, I got the exact same thing as the original. So I'm going to say, therefore, even. Okay, so that was a of x. Let's do b of x. B of x equals, what if I gave you 5x to the third minus 2x? Again, start the same way. Plug in negative x, and I get 5 negative x cubed minus 2 negative x. All right, so negative, though raised to an odd power, will indeed result in negative. So negative 5x cubed, and then negative x, I'm going to put that in front, so combine it to be plus 2x. All right, clearly looking at this, I'm going to say this does not equal the original. However, so it's not even. To test then if it's odd, this here would be equal to negative b of x. So let's see what negative b of x is. Negative b of x means I multiply the function by negative 1, so the whole function. So if I multiply the whole function by negative 1, I get negative 5x cubed plus 2x. Is that equal what I got? Is it equal to what I got for b to the negative x? And it indeed is. So this actually equals b to the negative x. So by the definition of odd, when you put in a negative x, it should be negative of what you get when you put in the positive x. That is odd. So that is how you're going to test. First, you always put in b to the negative x. Quickly, you'll see if it's even or odd. If it's not even, see if that equals negative b of x. And if it does, then it's odd. If it doesn't, then we're talking neither. So if we look to some other problems that got a little bit more complicated was, let me just give you a simplified version of this. Say I told you a of x is even and b of x is odd. And I asked you to determine if the following is even, odd, or neither. So what about the function, we'll call it f of x is going to be equal to this particular composition, b of a of x. Okay, so the way I test is just as before. Always start by plugging in negative x. So there's only an x in the inner function first because it has to go through that. But a of x is even. So a of negative x is just a of x. So done. we saw that f of negative x, we just get back f of x. So we're going to say this is even. Let's do this though. What about if I asked you to find even, odd, or neither, g of x equals a of b of x? Okay, so again, plug in negative x, and I'm going to have a of b of negative x, and b is odd, so b to the negative x equals negative b of x. So now I'm saying A of some negative B of X. But because A is even, A of negative something is the same as A of B of that something. So A of B of X. So it turns out that both compositions, so this is, since it equals G of X, it's even. Both compositions here ended up being even. And so I like to, you're going to see this on the back sheet in particular, I like to start off by always putting in negative X and work inside out with those type of composition problems. Okay, hope that helps.